I know we worked on this question in class, but I just wanted to give you another chance to see that material and see this process, right? So in class, we answered this question of having 75 milligrams of caffeine with the formula CaH10N4O2. How many molecules does that represent? So to answer this question, we had to start with milligrams and go to grams. So we had to use the metric system for that, because once we're in grams, we can go and find the molar mass of caffeine using the periodic table. And we know that the molar mass relates grams to moles. And then once we find moles, we can find the molecules using Avogadro's number. So first things first, let's find the molar mass of caffeine. We've got 8 carbons at 12 AMU each. We'll say 12.01 AMU. I have 10 hydrogens at 1.01 AMU. I had 4 nitrogens, and nitrogen is 14.01 AMU, we'll say. And then 2 nitrogens, or 2 oxygens, and oxygen is close enough to 16. So I've got 32 from the oxygen. I've got 56.04 from nitrogen, 10.10 from hydrogen, and then 80 plus 16 more, 96 from carbon. Add those all up and I get a molar mass of 194.22 grams per mole for caffeine. Right, so let's start our calculation now. We can go from milligrams to grams because we know that in 75 milligrams, right, for every 1,000 milligrams, I have 1 gram. 1 gram. So we divide by 1,000, I've got 0.075 grams of caffeine. Now we can use that molar mass because the molar mass relates grams to moles. So I know, right, for every 1 mole of caffeine, I would need to have 194.22 grams of caffeine. So 0.075 divided by 194.22. Got 3.8616 e to the -4 moles of caffeine. So that was step 2 hidden in right there. Step 3, now we can go from moles to molecules. And so I've got 3.8616 e to the -4 moles. Right, Avogadro's number tells us, right, for every 1 mole that I have, we have 6.02 e to the 23 molecules. So I'm multiplying by Avogadro's number, right? Moles cancel out. So times 6.02 10 to the 23. And I get 2.3 e to the 20th molecules. So for significant figures, right? 2 significant figures, 2 significant figures, because 75 milligrams only has 2 significant figures. So we should get comfortable with these steps of going from grams to moles using the molar mass, and then from moles to molecules using Avogadro's number. There's one more calculation we can do after this, and that next calculation would be, okay, now that we know how many molecules we have, how many atoms, how many of a specific atom do we have in this sample? And so that's the next question that we did in class was, okay, saying, that we have all of these molecules, we had, 2.3246 e to the 20th caffeine molecules. Right, I then asked how many nitrogen atoms do we have? And this was kind of a challenging step to make for some students, but what we want to see is that for every 1 molecule, right, for every 1 molecule, of caffeine, I'm gonna have 4 nitrogen atoms, right? So molecule cancels out, and I'm gonna be left with 4 times that, so multiply that by 4, because right, in every one molecule, there are 4 nitrogens. I know the number of molecules, I'm gonna have 4 times as many nitrogens. And that leaves me with a number, again, to 2 significant figures, about 9.3 e to the 20th nitrogen atoms. And as I was talking with a student about this problem after class, right, to kind of help understand that calculation, right, for example, a similar calculation would be, let's say we had 20 chocolate chip cookies. And this will make more sense in a second. And we wanted to know, in those chocolate chip cookies, right, how many chocolate chips do we have, right? So the molecule is the entire cookie. And then we're asking, okay, in that entire thing, we have 4 of these nitrogens. So how many nitrogens total do we have? Be the same thing here. If I had 20 chocolate chip cookies and I knew, right, for every 1 cookie, right, I had 5 chocolate chips, we'll say, on average, right? Cookies cancel out, and we're going to have 5 times as much, right? We would have 100 chocolate chips. So that's the same kind of calculation that we're doing here. We found molecules. So how many number of molecules do we have? And then when I asked you, okay, within that sample of molecules, how many nitrogen atoms do we have? We had to look at the individual molecule to see there were 4 nitrogens. So we're going to have 4 nitrogens for every 1 molecule. I need to multiply that by 4. In the same way, if we had the total number of chocolate chip cookies, we wanted to figure out how many chocolate chips, right? We're going to multiply the cookies by how many chocolate chips there are per cookie. Our molecule is the cookie in this case. So hopefully that analogy helps try to figure out that relationship when we're doing a calculation like this and finding from molecules to atoms.